Alrighty, well, happy Thursday. We're going to finish up our chapter here on containers, the abstract data types in the standard template library. So there's not too much more for us to look at container-wise, but when we left off here, that's not even the right one. Nope. Go back to the right one here. Was using find, I think was pretty straightforward to find something in that container, so that one's not too bad. But sort was pretty interesting. There's a lot of things happening with sort so that we can go and determine how we want items to be sorted if it's not the natural order. So all of that relies on using the less than operator. So we need to be able to say, hey, is this value less than another value? Right, if we wanted to sort those. And then where do we start and where do we end, right? One past the last element, usually with the end one. So sorting numbers is pretty easy. Sorting names we can sort. That works out pretty well. Doing pointer arithmetic is a little silly. I think that was one of those things that was on the practice that we mostly ignored. Do you remember doing any pointer arithmetic? Maybe. Okay, so that's fun to look at here. So if we want to use the iterators ourselves, why don't we start up at the top here? Excuse me. So we'll do scores. We'll add a bunch of scores. All right, then okay, we'll go this way. So if I get the front of my scores list here, my vector here. Right, I should get, oh no, hang on. It's begin. There it is. The beginning of my scores vector here. That's an iterator. The iterator is just serving as a pointer for me. Right? So if we say, hey, my auto beginning is scores of begin. Right? That's my vector of type integer, : iterator for beginning. And if I wanted to see out the beginning, doesn't know what to do with it here. So you don't have something that matches an iterator in this one here, right? So that gets to be a little funny, right? Can't take that one directly. We should be able to dereference that. Say, hey, just like you can take the value that a pointer is actually pointed at by dereferencing it, we can say, hey, let's dereference this and let's see what we get here. So let's put our breakpoint in. So what's the first score we should add?
10.
10? All right, and then maybe 20, and that's probably enough for now. All right. Oops, not shrink. So the first thing we want to do, right, we have our iterator. It points at the value 10, right? It is a pointer here behind the scenes. So our iterator knows it's actually a pointer. It's just fancy here. And then when we output here, we get our 10, which is fun. So then we can take our beginning pointer and we can add 1 to it. And let's try and see out it again. Put my breakpoint here now. Right, so let's do 10. Oh, okay, sure, 02 instead of 20, that's fine. So the first time it was 10, right, pointing at 10. Then we're going to increment our pointer, and now points at the next value, it points at 2. So we've changed the value of the pointer 1 memory address to the next one, essentially here. And that's kind of cool. And then we output that one, we get the next one. So if you want to, you can iterate over something using your iterator and not our enhanced for loop here. This is actually what this loop is doing here. It's essentially getting this iterator out, starting at the beginning, iterating through the end here. We could do it by hand if we wanted to, right? So if we do that and then we do beginning plus plus again, what do you think we're going to get a third time if we only add 2 items? Probably don't need all the breakpoints, do we? That's fine. Is it running? Okay, so we'll do 10 and 20, -1 to stop. So beginning gets updated, and now it points at something. You think we can dereference this one? Can't dereference out of range vector iterator. It broke. Okay, so doesn't allow you to use the iterator. We can't dereference it after it's out of range. So that's one of the things the iterator knows about itself, is it knows where its range is. Right? So this is a little silly to do it one at a time here, but maybe we say, I think we can say while beginning does not equal my scores dot end. That way. Right? And also gives me an iterator. We should be able to see out the dereferenced beginning. And we should be able to take our beginning pointer and add 1 to it. Right? We should be able to loop through ourself here. So 10 and 20 and -1. So right now our beginning pointer points at 10. We updated it. Beginning pointer points at 20. We updated it. Beginning pointer points at some nonsense. Whatever that nonsense is the score's end. Right? Wherever that thing was, right? That's the end of the line here. Right? That's one past our last valid item here. So if you want to, you can use your iterator and you can do arithmetic with it one at a time. Right? We could do the same thing with our dynamic arrays and our pointers. I think we skipped over that because it was a little bit annoying here, but if I wanted an int array of dynamic scores array, this new int of, I don't know, we'll say size 5 or something here. I'm doing it in the wrong spot, aren't I? Let's go over here. Nope. What am I doing wrong here? I never use these because they're obnoxious. Just say int dynamic scores. Is that it? Probably looks close. I have to go look again. I try not to use these. Right. So then our dynamic scores, right? The value here is, remember, actually the start of this array. And when we say, hey, index 1, it takes that value and adds the size of 1 int to it, or adds the size of 2 ints to it to get at the particular index that it's getting. And it does that arithmetic because it gets one big block of memory, and each item is here, 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 as we go. So you can take your dynamic scores pointer, and you can like add something to it. You know, add 2. Right? And then we can get out the value here. So you can do similar things like with our iterators, that's all. Let's see how dynamic scores. Let's see what this one does for us here. Oh, we never gave it any values either. So dynamic scores at 0. We should do a loop. We should do a loop for index is 0, index is less than 5, index plus plus. Our dynamic scores at the index can equal index plus 1. Why not? So we get 1, 2, 3, 4, 5. 10, 20, stop. Oops, -1. There we go. Try the right value here. All right, so we don't need that one. We can continue past that one here. Oops, there we go. All right, so now our dynamic scores, right, is our array. But in debug mode, it doesn't look very nice. We can't actually expand it out, which is really sad, like you kind of vector. So we just see the first value. So we see dynamic scores. There's the memory address. There's where 1 is stored here. So if we go and add to it here, dynamic scores now points at the third value, because we added 2 values to it, essentially here. So we output, we should get our 3. Oh, I'm sorry. We get the memory address. That's right, because that is the actual value of it. If we want what it's pointed at, we could dereference it. Let's do that. So let's stop here. We can say for int, I don't know, let's value 0, value is less than 5, value plus plus. We'll take our dynamic scores. We'll say this is the address. Is that, and then we'll do the value is the dereferenced dynamic scores. I'd help if I spelled that right. Okay, so you should be able to see what address it is. Then you should be able to add to it, and we'll take dynamic scores plus plus. That one should be fun. All right, 10, -1 to stop. We say, okay, so at whatever this memory address D0, the value is 1, D4, right, 4 bytes later, is an integer sized 4 bytes. Way back when we talked about that, most of the time we don't care, right? And then 8 bytes, and then in hexadecimal, because this is hexadecimal notation, this plus 4 gives me C, right? Because we go to A, B, C, D, E, F instead of rolling over because it's base 16. It's not that important, that's okay. And then 4 more gets me back to E0. Okay, so we can see it's just a pointer, just like our iterators are essentially. They're just fancy pointers. All right, so how we can use sort then, if we want to sort something, is going to sort with the lesson operator. Right? So one of the things we looked at, so if we made a custom class, this is going to be hard for us to sort, right? So I think we did a student class, created a class for student. Nope, that's the wrong syntax here. Private section and a public section. So we had a string for name and an int for number. It's probably enough for now. We don't need too many things here. So include string, and using our namespace standard. Oops, and then we want a student. We'll take a int for number and a string for name. This number is the name is the name, and this number is the number. And then we need some get methods here. So we'll have a string for get name, returns name, and an int for get number. Number returns the number. All right, we don't need any sets right now. So if I want to put a bunch of students in here, are they going to sort for me? Probably not very well, right? So let's include student. Include. That's should rename that to an H file here. There it goes. If it wasn't an H file, it doesn't suggest it to be included here. It technically still works as a CPP file. It just gets a little funny here. Student.h. Okay, so let's make a vector of type student. Students. Now let's add a couple students. So we'll take our students and we'll push back a student. Let's see, I need, was it name or ID number first? It was number first and then name. So let's do number 1 for Eric, and students push back a student. Number 3 for Jeb, and students push back. Oops, can't spell student. There we go. Student. Let's try 2 for, we'll add Journey. So if I want to sort, right, I've got my algorithms here, so I should be able to call my sort function, right? Tell it where to start, where to end. So I want to sort. This is my students.beginning, and I want to end at the students.end. Right? And then maybe for student, student and students. Maybe see out student.getName. We'll just do the name for now. Right? What kind of order are we going to be sorted in here? Uh-oh, we have build errors. Did we? What's my build error? Where's my, there it is. Ah. Call to object of class something something standard less. No matching call operator found. Looks like a bunch of nonsense here. That's an algorithm. it can't sort because there's no less than function. That's essentially what it's saying, right? We can't call less than. We don't know how to see is one student less than another student, right? So we've got options. We could add a less than operator, right? So we could write a Boolean operator less than, right? That takes a student reference other, right? So we can write our own operator functions. Say, hey, this is how you do the less than operator. To do that, you need two students, right? You're the one being acted on, and then you have an other student. I think it's a reference. Pretty sure it's a reference to it, another student here, because you don't want to have to pass a copy or anything like that. So what should we sort on? Should we sort on number, maybe? So we can return number less than other dot number. So if my number is less than their number, I'm less than, right? If our numbers are the same, we're not less than, because we're the same number. And if my number is greater, right, I'm still not then. So it's only true if my number is less than theirs. Should we try that? Look, and now it runs. So we should now, right, we have our vector of students in here. We've got, right, Eric with number 1, Jeb with number 3, Journey with number 2 in indexes 0, 1, and 2. After we sort now, they changed. Right now we're number 1, number 2, number 3 in order, because that's what we told it to do, to sort by number. That's our default sort in our class for student. We can have our operator here for less than,
so
which is
sorting the numbers change their position in the vector.
Yeah, so it moves them around in the vector into a sorted order. So it will sort them in place in that vector. Yep. These are way too low. Let's get higher. I don't know. I can't even use these numbers.
By name would it put them in alphabetical order?
If that's what we tell it to do, yeah, that's what we're going to do next. So you can tell it, you can give it specific sorts by giving it a compare function. You can say, okay, this is how I want you to compare them. So a compare function takes two elements and compares them here. So we can write a function. It doesn't have to be in the student class. This can be our own function here. So we're going to have a Boolean for compare students that takes a student reference, I don't know, student first and student second, or left and right, or I don't know, whatever you want to call these ones here. So we're going to return first.getName is less than second.getName. Right? Because strings are sortable, right? Because it will just turn them into their characters and compare by character, right? So if we want to sort, then we can give it a sort function. I can say, hey, when you sort, use this compare students function here. This looks super weird, right? This PR, it's really weird looking when we give it a function. Now when we sort, here, our students list, they're sorted alphabetically. Oh, we were already sorted alphabetically. Oops. Maybe we mix that up here. Let's, I'll add me last. How about that? Let's restart. Okay, so now our students list, we are not sorted alphabetically. Once we call sort, now we're sorted alphabetically because we gave it, here's the way that you can compare these two things, right? So this one's nice because it doesn't have to use the operator less than. Right? You don't need that defined in this function because we're giving it a function here. So we could comment this one back out if we wanted, right? And this should still run for us because we told it, here's the function to sort. But if you don't give it a function, it looks for the less than operator. It says, oh, I'm going to sort normally, which is less than. Right? Is this one less than? 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 And sorts them all that way. So that's really fun. So we can sort custom classes then with their own type. Oh, here's student. I forgot they did the student one here too, right? So you can compare first name, compare by last name, compare ID number, any sorts of different compares that you want here, right? Whatever we want to write, we can sort them all out with those sorts. Is that fun? Yeah.
So when you do the operators, can you only do less than?
No, we can do any of them that we want. There we go. So when we do operator, come on, doesn't it give me more of them? Greater than or equal to, I think we can do as a function, isn't it? Isn't that what I did? Student reference other. Yeah. Okay. I just need to finish typing. So C++ operator overloads. See if we get a whole list of them here. C++.com. Operator plus plus. That's not a very great one, is it here? Where's C++ reference? This one to follow maybe? The operator type. Operator equal. Operator. None of those are. It's just like I just want like a nice list. That one's not even really pretty here. This one's fun. You can give it the insertion or extraction operator as well when you define these. So if you want to be able to see out a student, you can say, hey, I want to give you the operator arrow arrow. This one's a little weird because it's supposed to return the object stream and take an object stream. Because as you're throwing things out with this extraction operator, right? Or no, the insertion, whichever arrows these ones are, right? We can chain them together. So if we don't have the return here, you can't chain them all together. So this lets you add it into the stream and then give the stream back to whatever's using it. So as we work on those, like as we output things in our stream, right? We do something and then something else and something else because it returns the next one, right? Things operate left to right. So here's the out, and then we are adding this one to the output stream, then we're adding this one to the output stream, we're adding this one to the output stream, on and on and on as we go. So those ones are fun that you can do those. You can do increments and decrements. Sure, that's fun. Right? If you want to define how you increment and decrement, comparison operators, here you go. Greater than, less than, greater than, or equal to. Equals, not equals, we can do. You can do your array subscript operator if you want your class to say, hey, I can get an index out from this class, which is fun. Okay, this was a better list here. You can do your bitwise arithmetic operators. Oh my goodness, please don't do those. That sounds awful, right? But yeah, you do all sorts of crazy fun things here, overloading the operators. To say, hey, my class should work with these things. And if you don't, that's okay. You don't have to define them because they don't always make sense, right? You shouldn't be able to add two students together. That doesn't really make a lot of sense. Why would I have a student plus a student? No. But other examples, right, when they deal with like points. Right? Hey, here's an x coordinate, here's a y coordinate. I could turn them into a class. I can add 2 points together and do some sort of, you know, now I'm going to combine the 2 points and get the x's added together and the y's added together or something. Right? I can do some transformations. So you can do fun things with those. All right, so that was our operators, so we can do sorting. Sort's a lot of fun. So we'll get into using our greater thans and less thans in our own custom classes later. We're not going to do that just yet, because we're just now getting to it. All right. So how's everything going with the project? I did get one question. Someone ran into a good problem. As you store something in character, if you have an attribute for weapon, depending on how you store this weapon, it will do the right thing polymorphically, or it will always be a weapon. Right? So what do we need to store this type as to make sure that it will polymorphically call the right version of get damage based on what our weapon is? Right? With our virtual function. If we want our virtual functions to work polymorphically, the types we need to use are pointers. Right? You can't just have just an instance of weapon. You have to have a weapon pointer. So when you call get damage at runtime, it will find the right version to use. So that's one of those things you'll probably run into if you are running it and it's not doing what you expect it to do. It's probably because you're not using a pointer here for that. Right? That's all. So I think that was a good takeaway. So we're going to do.
Yeah, it's like a string pointer.
So weapon is a class, so it'll be a weapon pointer, right? Because that's our own class that we wrote. But if we don't declare it as a pointer type, when you call get damage, if you gave it the healing stick, it doesn't do the right thing, right? You won't get that overridden version of it, right? Because it's got to be pointers all the way down for polymorphism to work right, because that's what enables it to do that at runtime. It'll go look up what it actually is when it's stored.
Then what do we have, like, set it as the attribute for in the here?
Yeah, so it'd be a pointer. So like you could have an int pointer, I don't know, number reference or number pointer, right? You just declare it as the pointer type. That's all. Yep, so that'd be your weapon pointer. So then when you pass them, right, you have to pass a pointer to it, right? That's all. So couple pieces there. We don't have to manage any dynamic memory, thankfully. Like they'll just destroy on their own. We don't need to write custom destructors because we're not allocating dynamic memory. In our main class, if you're writing a main loop or something, you can allocate pointers, allocate memory all you want, right? It'll get cleaned up when we're done, right? Or we can delete them ourselves if you care to. We're probably not going to do that many.
For the lab, it would tell, like after I did the virtual class, it asked me for a virtual destructor, I think. So do we always need that?
For the lab
Yeah,
form?
for this lab.
Well,
Like, I kept getting like the green messages. It's like, oh, I think it was virtual or something destructor. It needed me to actually create one.
so the green ones are like suggestions,
Yeah.
right? Not an error. So you don't have to have it, but it's saying, oh, hey, if you're doing this, you probably want to add a destructor.
So what do you think? Like, do we always need to add a destructor if we have virtual, or it doesn't really matter?
So if your class is allocating dynamic memory, you need the destructor.
Okay.
If it's not, it'll get cleaned up eventually on its own.
Okay.
Like there's no special handling we need to have a destructor
Okay.
there. Yep. Yeah. Awesome. All right, so that's actually all we got today. Not too much else going on right now. So we got a little more time to work on the project then. That sound good? All right, cool. I will see you folks on Tuesday then. So we've got one more week now for this project. So I'll go over the answer next Thursday. We'll go over a solution to it, okay? All right, thanks folks.